Chapter 21, An Introduction to Organic Chemistry. In this chapter, there are three sections. The first section is about organic compounds. Second section is about petroleum and natural gas. And then last but not least, competing uses of petroleum. What are organic compounds? All organic compounds contain carbon. And most organic compounds also contain hydrogens. And you need to know the definition of hydrocarbons. Hydrocarbons are organic compounds that contain only hydrogen and carbon. In other words, hydrocarbons are organic compounds that contain only hydrogen and carbon, and there are no other elements inside except hydrogen and carbon. Some other organic compounds may also contain oxygen, chlorine, nitrogen, and so on. So as long as they contain other elements like oxygen, chlorine, and nitrogen, they are not called hydrocarbons, but they are still organic compounds. The next thing to study is homologous series. To study the different organic compounds, the related organic compounds are grouped into families called the homologous series. So for example, alkane, alkenes, alcohols, and carboxylic acids. These are the four homologous series that you need to study in the O-level syllabus. Now the definition of homologous series. A homologous series is a family of organic compounds. So it's a whole family of compounds with the same functional group and hence having similar chemical property, because the functional group will determine the type of chemical property that the compound has. Now, next definition is, what is a functional group? A functional group is an atom or group of atoms that gives a molecule its characteristic property. In other words, the type of chemical reaction it can have. And in the fourth family, you need to know that alkane has no special functional group. That's why the type of reaction it has is quite limited. But alkenes, alcohols, and carboxylic acid, they all have their very distinctive, unique functional group. For example, alkene has this structure, carbon, double bond carbon. It's called a carbon-carbon double bond. So it's carbon to carbon double bond. And the alcohol has this, looks like hydroxide, but it's called hydroxyl group. Hydroxyl is not hydroxide, it has no charge. It's a covalently bonded -O-H. As for carboxylic acid, it has this C double bond O-O-H, so it's called carboxyl group. In short, it's called COOH, the carboxyl group. So these are the functional groups of these three families. And this functional group gives all the members in the same family having the similar kind of reactions. Now, what are the general characteristics of a homologous series? So within a homologous series, they all have the same functional group. Because of the same functional group, they all have similar chemical properties or similar reactions. However, they have gradual change in their physical properties down the series. For example, the melting point, boiling point, density, and so on. Okay, so let's try this question. Which of the following statements about a homologous series are correct? Number 1. All members undergo similar chemical reactions. Does all members in a homologous series undergo same chemical reactions? Answer is yes. Number 2. All members have the same functional group. Is it true that all members in the same homologous series must have the same functional group? Yes, definitely. And the third one is, all members have the same physical property. In other words, do they have the same boiling point, melting point, or density? Obviously not, because the physical properties will vary. For example, the boiling point, it will vary slightly from one member to the next member and so on. So answer is 1 and 2 only. Answer is A. Now, because there are so many members within a same homologous series, they need to know how to name them. So within one family, we name them by the number of carbon atoms present in the molecule. If the molecule has one carbon atom, then the name will start with Me. If it has 2 carbon atoms, then it starts with E. If it has 3 carbon atoms, it starts with Prop. And a 4 carbon atom, it starts with Bute, and so on. Okay? So you need to know, according to the syllabus, you need to know until the 4th one. But if you want to know the rest, they are here. 5 is pent, like pentagon, 5-sided. Hex, hexagon, 6-sided, is 6 carbon. Hep is for 7, oct is for 8, non is for 9, and dec is for 10. These are the number of carbon atoms in each molecule. Now, the suffix shows the homologue series. In other words, after naming the number of carbons, you must tell me which family it is. For example, the alkane family will end with A and E. Alright? And the alkene family will end with E and E. Alcohol family will end with OL. Okay, but of course you remember that it's ANOL. Okay? So for example, when there are two carbon atoms, it starts with E. So under alkane is ethane. So 2 carbon is E, alkane family is ane, so it's ethane. In the alkene family, it starts with 2 carbon, it still starts with E, 2 carbon, and the family's name is ene, so it's ethene. So how about alcohol with 2 carbon? It still starts with E, ETH. Because it's alcohol, so it's ethanol. Now the last one is a carboxylic family. Okay, so it has a enoic acid at the back. So what happens is that it has 2 carbon, but it comes from the carboxylic family, so it's called ethanoic acid. Now let's look at an example at the bottom here. You can see that this C equals C, this is the carbon-carbon double bond. And this is the functional group of alkene family. Previously we saw that alkene family has this functional group called the carbon-carbon double bond. Alright, so this alkene family. And inside this molecule there are 3 carbons. So it's prop. 3 carbons is prop. So it's called propene. That means in this alkene family with 3 carbons it's called propene. Now the next example on the right, there's a OH. This is called a hydroxyl group. Not hydroxide, hydroxyl group. Hydroxyl means alcohol. Alcohol always ends with ano. Even though it says O, but actually you must remember it's spelled as ano. And then because there are 2 carbons inside, it's called ethanol. Alright? So first part of the name is always the number of carbon atoms. Second part is the family name. Now, so this is the summary of all the 4 family, the first 4 members of the 4 family. Now remember, alkene needs a carbon-carbon double bond. So alkene, there's no single carbon because minimum you need is carbon and carbon double bond. So there's minimum 2. That's why you have something called ethene. So let's look at alkane family. Yeah? All the name for alkane family ends with ane. When there's 1 carbon is me, 2 carbon is e, 3 carbon is prop, and 4 carbon is bute. So together you can call it methane, ethane, propane, and butane for the first 4 members of alkane family. Now alkene need to have at least 2 carbons, so it starts with E, 2 carbon, and the family name is ene, so it's ethene, followed by propene, 3 carbon, butene, and that is a 4 carbon. Now let's look at the next column, the alcohol family. Alcohol has an ano, ends with ano. So 1 carbon, if you look at the front, 1 carbon is always me, so it's methanol. 2 carbon, ethanol. 3 carbon, propanol. And 4 carbon is butanol. It's very simple, right? It's always the number of carbon followed by the family name. Then the last one is carboxylic acid, is always enoic acid as a family name. So with 1 carbon inside, it's called methanoic acid. And 2 carbon is ethanoic acid, 3 carbon is propanoic acid, and then finally with 4 carbon is butanoic acid. That's how we name the first 4 members of all the 4 families. The next section is petroleum and natural gas. So we need to know that petroleum is a mixture of hydrocarbons, and then you need to know natural gas and petroleum are the sources of energy. In fact, they are actually the fossil fuels. You must know how to describe, usually a 3-mark question, how petroleum is separated by fractional distillation. Okay, petroleum is separated by fractional distillation. And last but not least, name the fractions of the petroleum fractions and state their uses. It must be in the order of from the lowest boiling point to the highest boiling point. So what is petroleum? Petroleum is a natural occurring mixture of hydrocarbons, and these hydrocarbons are mainly alkanes. That's not the first memory we learn. So petroleum is a natural occurring, occur naturally in the nature, in the ground, under the ground, or under the seabed. It's a mixture of hydrocarbons, and sometimes they also call crude oil. So whether they refer as a crude oil or petroleum, we refer the same thing. The next one is natural gas. Natural gas is what exists on top of the petroleum. It's actually gaseous. It's a gaseous state at room temperature. They are made up mainly of methane. Okay, methane is the smallest molecule of the alkane family. So natural gas and petroleum are all alkanes actually. Methane is the smallest member with one carbon inside the alkane family. And this natural gas is about 70 to 90% methane, and the other smaller percentage are like ethane or maybe propane and butane and so on. Okay, this is a mixture in the natural gas. So you need to know that petroleum and natural gas are sources of energy. They either burn to produce energy like heat and light. Now, so how are petroleum and natural gas formed? Okay, this is not very important, just for information. So these are based on whatever we know is that they are from the sea creatures and plants that sink to the bottom of seabed when they die millions of years ago. And these organisms are then subjected to heat from the earth and the pressure when the sand cover them up and they go under. So under high pressure and temperature, they slowly convert into petroleum. So petroleum and natural gas are formed under millions of years of pressure and temperature, and you need to drill deep wells in order to get them out. So for example, between this layer of rocks, you can see, and this layer of rocks, the impervious rocks, that means the liquid cannot flow through, there lies the black layer of petroleum and of course some natural gas. So you need to drill all the way down through the bed, okay, through the sand, to the rocks, to reach the petroleum, and then the petroleum can come out through pipes, okay, and then be collected. Now that you have understood how natural gas and petroleum were formed through millions of years of chemical reactions, millions of years, hence they are called fossil fuels. Okay, so suggest one characteristic of fossil fuel. Well, they are non-renewable sources of energy. Why? Because they take you millions of years to produce, and then they cannot be produced easily. So let's see what's the meaning of renewable and non-renewable. Anything is renewable source of energy are generally defined as energy that can be collected from resources that are naturally replenished in our lifetime. For example, it takes you between up to 70 years, 80 years, and then it can be replenished again. These are called renewable energy. For example, sunlight, okay, solar energy, wind energy, and so on. And even geothermal or hydroelectric, all this energy they can be replenished again and again. So it's called renewable. Non-renewable source of energy are the kind of sources that actually run out, okay, or not be able to replenish in our lifetime or even many lifetime. For example, it take you a million years, we can never see replenished actually. So non-renewable resources are something that you use up and then you will never be there anymore. So they're all called fossil fuels. Okay, for example, coal. Okay, once you dig up from the ground and you burn them, you won't be there anymore. Petroleum, likewise, when you actually get them off from the ground and then once you use it, you burn it away and you won't be there anymore. And of course, natural gas. These are three fossil fuels and they are non-renewable. And carbon is actually the main element in the fossil fuel. As you know, when carbon is burned, it produces carbon dioxide. So in other words, fossil fuel are actually producing a lot of greenhouse gases, carbon dioxide. Now, which of the following statements about natural gas is correct? Let's look through. A. It is obtained by fractional distillation of crude oil. Does the natural gas obtained from crude oil? Is it a renewable source? Obviously not, right? Natural gas is a fossil fuel, it's not. Is it contained mainly of methane gas? That sounds like quite true. And then produce large amount of soot on combustion. Actually, we haven't learned that. But methane is the smallest molecule, so less likely to produce soot. So answer is actually C. Okay, mainly methane, we learned just now. Other than methane, which make up maybe 70 to 90% of natural gas, the other gases could be ethane, propane, and so on. The other alkane family. So fractional distillation of petroleum. Okay, remember this is a 3-mark question to describe how, the syllabus, look at syllabus on top. Describe how the petroleum will be separated by fractional distillation. So first of all, you must always mention that petroleum can be separated into the useful fraction by fractional distillation. Now, fractional distillation is based on difference in the boiling point. Okay, difference in boiling point. So each fraction is a mixture hydrocarbon and it boils over a certain range of temperature. The lighter fraction contains fewer carbon and has a lower boiling point range than heavier fraction. Now the lighter fraction refers to smaller molecule. Okay, smaller molecule. And of course they have fewer carbon, and then of course they have lower boiling point. Now let's look at how they describe. First of all, you must mention the petroleum is separated by fractional distillation. So first step, the petroleum liquid is heated and turned into vapor in the furnace and then passed into the fractionating column. So this whole thing is the fractionating column. So what happens is that when the vapor go in, it will rise. Okay, you rise and you rise and so on. So the hot vapor cools and condense, the two keywords, cool and condense, and it rises up the column. So as it rises up the column, it starts to cool and condense. Now the lighter fraction, the smaller molecules with a lower boiling point, are collected at the top, while the heavier fraction, the bigger molecule with higher boiling point, collected at the bottom. And therefore the fractions are being separated into the 7 fractions down here. You have petroleum gas, petrol, naphtha, kerosene, diesel oil, lubricating oil, and bitumen. Now, petroleum gas is out of syllabus, okay, but you still need to remember that this is the first position, and then followed by petrol, naphtha, and so on. Take note of the spelling. For example, naphtha, N-A-P-H, P-H pronounced as F, naphtha, T-H-A. Kerosene, diesel oil. Okay, sometimes I read it as diesel oil. Easy to remember the spelling is diesel, D-I-E-S-E-L, diesel oil. Lubricating oil, and of course bitumen. Okay, these are the 7 fractions. Now take note of the difference between petroleum gas and petroleum. Petroleum is the entire mixture, and the smallest few molecules, for example the smaller molecules in the petroleum gas actually is only a part of the whole petroleum. So which statement about the fractional distillation of petroleum is correct? Is the liquid pumped into the column? No, right? It must be boiled into vapor to pass into the column. The fraction collected at the top has the largest mass. Largest molecular mass means the largest molecule, obviously is not correct. Fraction collected at the bottom has the lowest range of boiling point, also not correct. Okay, each fraction is a mixture of compounds. Yes. Each fraction itself is still a mixture of compounds. In fact, the entire petroleum is made out of more than 70 different compounds. And among the 70 compounds, you realize that it divides into 7 fractions, right? So obviously each fraction has a few compounds inside. So let's go through this. This is the key thing that you must memorize. Really need to memorize. Okay, for example, petroleum gas is used as a fuel. Fuel is important for cooking and heating. The petrol or gasoline, alright, depending which country you use this word. We usually call them petrol, but in some other countries they call it gasoline. Used as a fuel for cars or vehicle. Okay, cars is okay. Naphtha is a feedstock. Feedstock is a raw material. Raw material for petrochemical industry. Sometimes you can just say that, oh, it's raw material for making plastics and medicines. Okay, so it's petrol related chemical industry. So it's raw material for all this petrochemical industry, like making plastics, medicine, and so on, even making alcohol. Now kerosene, or you call it paraffin, is a fuel for aircraft engines. It can be used for cooking and heating also, but of course not in Singapore. And when kerosene is burned, actually kerosene has a very awful smell. Even if it's not burned, when it's vaporized, the smell is very awful actually. So if you use it for cooking, you need to have very good ventilation. If not, the whole place will smell very bad. Diesel oil is a fuel for diesel engines, for example, bus, lorries, trains, even ship also. Lubricating oil is not a fuel anymore. It's for lubricating machines, so reduce frictions in machine parts, or making wax and polishes. Even like candles is under this component. Next, the last one is bitumen. Bitumen is the largest molecules. They use for making road surfaces. Not making of road, but more of the surfaces. So actually road is made of many layers. There are gravels, there's sand, there are rocks below to make sure it's actually level. Before they apply this layer of bitumen, okay, the black, when they heat it to high temperature, it's become a very soft kind of solid, and then they put it on surface. It's to increase the friction so that the car will not skid on the road. Alright, and they allow some expansion and contraction when the weather changes, so it will not crack so easily like concrete ground and so on. So bitumen is very useful for paving road surface. And of course, the bitumen can be used for roofing to make waterproof roof. Now, you need to remember all the different components, the position. For example, petroleum gas, petrol, naphtha, kerosene, diesel oil, lubricant oil, bitumen. You must know the position as well as the users. So let's look at this. Which of the following petroleum fraction is correctly matched to its use? Is the bitumen used as a feedstock? No, right? The feedstock is actually naphtha. Is naphtha used for making road? Oh no, of course not. Naphtha is for feedstock and bitumen is for making road. So both are wrong. Is lubricating oil for making polishes and wax? Okay, yes it is. Okay, diesel is for jet engine? No. It's kerosene or paraffin that's used for as a jet fuel. Jet means airplane. Okay, so you realize that they have different uses, even though they are all used as fuel, but different kind of petroleum fraction are used for different kind of vehicles. For example, petrol is for cars, and then diesel is for the larger buses, lorries, and so on. Alright. Of course, one of the reasons is because you cannot be all using the same kind of fuel like petrol. If not, then all be competing for one single component, and then there won't be any use for diesel or kerosene, which is a waste lah. Alright, so this has to do with the competing users. So it's of course wise to have different kind of different fractions used as a fuel for different kind of vehicles, so they won't compete, and the price can be more reasonable in that case. Now the last one is competing use of petroleum. Okay, not only petroleum are used as a fuel, they also used as a feedstock or the raw material. So you need to know the issues related to the competing uses of petroleum. Now, if you look at this chart here, you realize this pie chart shows that 90% of the petroleum is being used as fuel. In fact, they will burn away. 90% of all the petroleum you dig from the ground, they actually burn away. They use to generate heat and electricity, to drive motor vehicles, to provide power for industrial use and so on, even in the power plants or so on. And then for 10% is a chemical feedstock. For example, making a plastic, detergent, medicine, fertilizer, and synthetic rubber and so on. Okay, why they call it synthetic rubber? Because real rubber actually made from rubber trees. Okay, rubber trees make the rubber. So actually, this is a synthetic rubber. So, why is there a problem with the competing use? If it's unlimited source, of course we are not worried. But the problem is that petroleum is a non-renewable resource. Non-renewable means that it's limited. Once you use up, that's it. Good luck. Okay. So to meet the two competing users, we need to conserve for future users. So there's a need for its conservation. Why conservation? Because you try to protect or preserve something so they can last longer. It cannot last forever, but as long as we conserve, okay, we can actually preserve it to last longer. So future generation will still be able to have a petroleum for use. Not only we don't have fuel if we run out of petroleum, we also run out of raw material to make plastic. Can you imagine a world without plastics? Actually, we can't imagine because we are so used to having plastics around. Something that's very durable, very light, very convenient, waterproof. So there's so many uses for plastics, alright? So one day when petroleum is gone, not only we got no fuel, you can't make even plastics. Now, so how to conserve petroleum? So of course, try to reduce the number of vehicles, burn lesser so it can last longer, take public transport, okay, or drive car that consume less petrol. Okay, so petrol comes from petroleum, and of course, if you want to get petrol, you must go and dig out more petroleum and so on. So if you use cars that actually use less petrol, for example, in some other country they may mix alcohol with petrol, so that you won't have 100% petrol reliance. You also have alcohol mixed with petrol. Alright, so use lesser, or even use like hybrid cars where they use electricity, okay, electricity and together with petrol. So you use lesser petrol for every kilometer you travel. Alright, so you try to use lesser. Or you can improve the design of power station or vehicles for more efficient use. Likewise, for example, 1 liter of petrol you can last you for instead of lasting you for 20 kilometers, if it's more efficient engine, it probably lasts you 100 kilometers. Alright, so they use lesser petrol, and then the petroleum will be able to last longer. You also want to use alternative energy sources. Other than car, of course, there are other energy. For example, produce electricity for the household. You may use solar energy, okay, or even nuclear energy for some country, because they need a lot of energy for the industries. Of course, they need nuclear energy. Okay, that's only applicable for countries with large land area, because any nuclear disaster, for a small country like Singapore, I think the whole country will be gone if there's any nuclear disaster. So only possible for certain countries, but not all countries also. Of course, there's also danger if there's terrorist act and so on. Nuclear plant can be very deadly kind of if it's being destroyed. It can destroy the probably up to 50 kilometer radius. Everything within all be gone. Okay, not talking about radiation that spreads further out. Okay, you can use alternative fuel also. All right. Now, alternative fuels are, for example, biofuel. This is just for information. You don't need to memorize all these things, but just have some information. For example, biogas. Biogas is produced when dead plants or animals decay in the absence of air. Alright. In fact, methane can be produced. Methane can be produced from decay of plant metals. You learned before. But biodiesel made from plants like palm oil. That's the reason why palm oil has become a commodity that is very valuable. In the past, nobody know how to use it, but of course they realize, hey, the palm oil, they actually can squeeze out the oil from the seeds, and this oil actually can use turn into biodiesel, can be used for power plants. So gas whole, gas and alcohol. Okay, so it's a mixture of ethanol and petrol. Alright, so ethanol is actually made from fermentation of sugar from sugarcane. So if you have a big plantation of sugarcane, you get the sugar, okay, and then you ferment it, you can get ethanol. So actually it's renewable. Why renewable? Because sugarcane you can plant sugarcane again and again. All you need is what? Rainwater and sunshine, and sugarcane will grow by itself. So once you cut down all the sugar canes and squeeze out the juice, you put the yeast inside for fermentation, you get alcohol. So alcohol is actually a renewable source of energy. So by adding alcohol and petrol mixed together, you realize that you need lesser petrol actually. Okay, that's all for the introduction to organic chemistry. In this topic here, you realize that organic chemistry actually talk about compound that contains carbon, hydrogen. And also, there are a few terms you need to know. For example, what's the meaning of homologous series? What's a functional group? What's a hydrocarbon? Okay, you must know some of these things. Alright, and then of course you also need to know, like for example, the fossil fuels are like petroleum, natural gas. They are non-renewable. Alright. And then the fourth family you need to know about it. You learn more about the individual characteristic later on, but now you just need to know that alkene has a carbon-carbon double bond functional group, and then alcohol has a hydroxyl, the OH functional group, and carboxylic acids have the carboxyl with COH functional group. Now, natural gas and petroleum. Natural gas is mainly methane. Okay, this is a very common question, yet a lot of people don't remember. So natural gas is mainly methane, and natural gas and petroleum, they are all both fossil fuel. They are important sources of energy. And of course, petroleum can also use as a chemical feedstock. Other than being burned as fuel, there's other uses. Okay, for example, making of plastics, so on, or even lubricants from petroleum. And petroleum is separated by fractional distillation. All right. And their 7 fractions are petroleum gas, petrol, naphtha, kerosene. Kerosene also called paraffin, diesel oil, lubricating oil, and bitumen. Now, you need to know the uses. Okay. Very specifically, if it's used as fuel, you must say fuel. For example, petroleum gas, fuel as a fuel for cooking, heating. Petrol as a fuel for cars, vehicles. Then you look at kerosene as a fuel for aircraft. Diesel oil is as a fuel for diesel engines like bus and trucks. Then for the rest, the other three, you don't need to mention the word fuel. Please don't mention that. Naphtha is actually a feedstock or raw material for the petrochemical industry. Lubricating oil is actually used to lubricate machines or even making wax and polishes. Don't forget about the wax and polishes. And bitumen is for making road surfaces or roofing. Alright, just remember, for road surfacing. Okay, users are very, very important. They always be tested.